All of the numbers that we're going to work with in this class and have worked with so far are real numbers. Real numbers live on the real number line. Positive real numbers live to the right of 0, and negative real numbers live to the left of 0. You then might ask yourself, is 0 positive or negative? And in fact, 0, also called the origin on the real number line, is not positive and it is not negative. So it's important to remember it's not positive or negative. If you had a number such as 2.5 and you wanted to find where it lives on the real number line, you would be plotting the graph of 2.5. 2.5 is exactly halfway between 2 and 3, so we would place the point, the graph of 2.5, we would plot it right here. The most important numbers that we'll be working with are integers. Integers live at evenly spaced intervals to the left and to the right of 0. The negative integers live to the left of 0, and the positive integers live to the right. They extend infinitely, as these arrows point out, and they can always be written as fractions with 1 in the denominator in their lowest form. So negative 6 is an integer because I can write it as negative 6 over 1, and that's its lowest, most reduced form. So you could have two real numbers. You can be asked to plot them like this. So you first put 0 in the middle, and you don't have to keep on writing out lots and lots and lots of marks like some of you might want to do. You look at the numbers you're plotting, in this case a half and 2.3, and make marks accordingly. So let's only go 3 to the right and 3 to the left. 1/2 lives halfway between 1 and 0, so let's go exactly halfway between, and there it is. There is 1/2. Negative 2.3 lives between negative 3 and negative 2. You have to make sure you realize that the negative numbers go to the left. So it's going to be to the left of negative 2, but not quite halfway to negative 3. So let's plot it right about here. So negative 2.3 lives right there. One useful thing you can do with a number line is figure out which numbers are bigger than other numbers, or vice versa, which numbers are smaller. So we could plot these numbers, negative 1, negative 2, negative 3, negative 4, and negative 5. So negative 5 would go right there, and negative 4 would go right there. Because negative 5 is to the left of negative 4 on the real number line, negative 5 is said to be less than negative 4. Similarly, you can write the same thing by saying negative 4 is greater than negative 5. Although this is more common because smaller is usually on the left. Although this is totally correct. You can extend this process to include more than two numbers. I could ask you to write these numbers in increasing order from left to right. And you would do that by plotting all the numbers on the real number line and then listing them as they are on the line from left to right. What would that plot look like? Here they are, all plotted on the real number line. So if I were going to write them in increasing order from left to right, the first number on the left is negative 2, and then you know that that's less than negative 3 over 2, which is less than 0, which is less than 1/2, which is less than 1.5, which is going to be less than 4. So you can extend this indefinitely to include as many numbers as you want. Another key term to be familiar with is the term opposites. And this has to do with numbers that are the same distance away from 0, but they're on opposite sides of 0. So for example, 4 could be here, negative 4 is there. Negative 4 and 4 are said to be opposites because they are both 4 units, in this case 4 to the right and 4 to the left, away from 0. This term is going to come up a whole lot when we deal with the concept of absolute value. The absolute value of a real number is the distance between the origin and the point representing the real number. The symbol A with the bars around it right there represents the absolute value of a number A. So for example, I could have the number 3. The absolute value of 3 would be its distance from the origin. The distance in this case is right here. As you can see, the distance is 3. So the absolute value of 3 is 3. Now, finding the absolute value of positive numbers is pretty simple because the absolute value of positive numbers will be the number itself. But what about going to the left? Let's say I went to negative 7. Well, what is this distance right here? Well, that distance is 7. So you would say the absolute value of negative 7 is indeed 7. How does this sum up? If a is a positive number, then the absolute value of a is equal to the number itself. So the absolute value of 3 is 3. If a is 0, then the absolute value of a is 0, because how far have you gone if you've gone nowhere? You've gone 0. And if a is a negative number, then the absolute value of a is going to be negative a. You have to keep in mind that that negative a is not actually negative. It's the opposite of a negative. The opposite of a negative is going to be positive. As you can see here, the absolute value of negative 3 is 3, because the distance, negative 3 is a distance of 3 away from the origin, which is just a fancy way of saying 0. So what are the important points you need to remember? All real numbers live on the real number line. You can figure out the relative size of two numbers by their placement on the real number line. To the left is less than to the right. And the absolute value of a number is its distance from 0. And another name for 0 is the origin. I hope you found this video useful.